Voice is audible, right? Okay, so let us start. Uh, the first question is tour plan. So let me read the question. Chef is going on a road trip and is trying to figure out how much it will cost him. His cab operator gives him the following rates: a fixed cost of X rupees that will cover up to 50 kilometers, and every kilometer past 50th has a cost of Y rupees per kilometer. So chef's destination is Z kilometers away. How much will he need to pay? Okay, so X, Y, Z are given in the question. So let me go to the doc. So this is the summarized question, right? What does the question say? Up to 50 kilometers, X rupees fixed. Okay, this is a fixed cost. Then above 50, we have Y rupee per kilometer. So if we travel above the 58 kilometer, he needs to pay Y rupee per kilometer. And Z is the kilometers he traveled, total kilometers he traveled, which is given. So what we need to find is the total cost. Okay. So from the this is a very basic question. First condition, what we need to check is that if the Z, like the given travel kilometer, is less than 50, then always X, that is the fixed rupees. Okay. So if it is less than 50, then always fixed cost. And if it is greater than 50, okay, then what will happen? Then the fixed amount will be there, obviously, plus the additional kilometers into Y. That is the additional kilometers he traveled and multiplied by Y. That is the Y is the Y rupee per kilometer. Okay. Now let me go to the code part. Okay. So here's the code. You can see that if Z is less than 50, then uh, we will see out the fixed cost, that is X, or else X plus Z minus 50 into Y. There's the additional kilometers and the cost per kilometer. Okay. So I hope this is clear, right? So you can see the test case also. 29 is less than 50. So the fixed cost gets printed. Okay. Then again, here 69 is there. 69 is there. So here the fixed cost is 500. So 500 will be there plus 69 minus 50 into 20. Okay. So I hope it is clear. This is a very basic question. Okay. So if it is clear, you can put thumbs up. Okay. Now let's move on to the next question without further delay. That is easy speaking. So let me read out the question. Chef believes that a word is hard to pronounce if it contains a sequence of at least 4 contiguous characters that are all consonants. Here, a consonant is every letter from A to Z except the vowels, that is A, E, I, O, U. Now, these are the examples that have been given. Okay, so let's first summarize the question. While summarizing, let me tell what is the word that is hard to pronounce? The word that is containing a contiguous sequence of all consonants whose length must be greater than equal to 4. Okay, so this is what is hard to pronounce according to the question. Now, the question uh, says that we need to check whether the given string S is hard to pronounce or not. If it is hard to pronounce, then yes, or else no. Okay, so let me analyze these test cases. They have explained the test cases very well in the question actually. The question is very much self-explanatory here. Uh, so let me take this example. S, Y, Z, Y, G, Y. Okay. See, S is a consonant, right? Y is also a consonant. We know all these are vowels, A, I, O, U. Other than these, all are consonants. S is a consonant, and till this, we have a length of 1, right? We need consecutive consonants and we need the length of them, right? For comparing that must be greater than equal to 4, then it is a hard to pronounce. Then it will be considered hard to pronounce. So S is 1, we count 1. Then Y is also consonant. So till this SY, length is 2. Okay. Then Z is also consonant. SYZ, length is 3. Y is also consonant. Length is 4. Right. G is also consonant. So length is 5. And Y is also consonant. So length is 6. So we have a consecutive uh, length of consonants, and the length sums up to 6, which is greater than equal to 4. So we can say it is hard to pronounce. Now, this test case, L is a consonant, right? So length is 1. Okay. Now, O is not a consonant. O is a vowel. We can't increment the length again. Now, C is a consonant, but we can't take LOC because O is a vowel. Okay. So we can't take LOC because we need consecutive consonants, right? So again, since we are getting a vowel, we can make the length. We can set the length to 0. Okay, because from C again we need to initiate counting again, right? So C is a consonant, so again we initiate the count. Initiate the counting. That is 1. Then K is a consonant. So CK is again length is becoming 2. S is also a consonant, so length is becoming 3. That is CKS, right? Length is becoming 3, CKS. Then M is also consonant, so the length is becoming 4, CKSM. Okay. So I is not a consonant, vowel. So we can't take this one. We need to start from here. T is a consonant. We need to start from here again. Okay. So T is a consonant, length is 1. H is a consonant, length is 2. So TH we have. So if we see what are the sequences we are having, L we are having of length 1, then C, K, S, M we are having, okay, of length 4, and TH we are having of length 2, right? So now we don't require this small sequences of length 1 and length 2 when we are having a sequence of length 4. Exactly 4 we are having, right? So do you think that we need to compare the small sequences every time? It's pointless to compare the small sequences. So it's best to compare the maximum maximum length that can be obtained out of the entire word, right? That is 4. So it's always, so from here we can get the idea that we are going to consider, we are going to take into account the maximum length of the subsequence. And we are going to compare whether it's greater than equal to 4 or not. So here we have CKSM, which is length is 4, right? Maximum length is 4, and that is greater than equal to 4. So it is hard to pronounce. So idea is clear, right? Now let's take an example which is not hard to pronounce. Scream only. Let me take the word scream. S is a consonant, so length is 1. C is a consonant, so length is 2. R is also consonant, so length is 3. E is again not a consonant, so we have SCR of length 3 till now. A is also a vowel, so we don't take into consideration. Then M is a consonant, which is of smaller length, so we don't need to bother. So SCR is of length 3, and 3 is less than 4. So it is not hard to pronounce. Okay. So I hope it is clear. Now let's go into the code part. Okay. So if we go into the code part, see. Yeah. So we take a counter, okay, that is taking into account the of the lengths which we are keeping on adding if we find a consonant, and this is taking into account of the maximum length. Okay, so we iterate on the array, on the string, I mean, then this is the condition that it is not, that it is not a vowel. If it is not a vowel, it is a consonant. Okay, that is any of the characters is not equal to A, E, I, O, and U. Then it is a consonant. So we increase the count, we increase the length, and every time we uh, every time we calculate the maximum length. Okay, only when we get it as a vowel, like this condition becomes false. Okay, when we reach a vowel, this condition becomes false. We go into the else part and we initialize the count to 0 again, which I have explained you in the while explaining the test cases. Okay, so at the end we have the maximum length which we are wishing to have, and we compare that maximum length whether it is greater than equal to 4 or not. If so, then we say that yes, it is a hard to pronounce word, or else. Okay, so I hope it is clear, right? Okay, then let me move forward to the next question if it is clear. Okay, let me read out the question. Question name: beginnings and endings. So an array A of length n is called good if the first element is equal to the last element, that is AI is equal to AN. You are given an array of length n. In one move, you can swap two adjacent elements of A. That is, choose an index I and swap AI and AI plus 1. Find the minimum number of moves needed to make the array A good. And if it is impossible to make, then print -1. Okay, so uh, summarizing the question we will do here. The question. So if what is good array according to the question is that if the first element of the array is equal to the last element of the array, then it is good array, right? Now the condition is that we can swap only two adjacent elements. That is, if AI is an element, we can swap AI and AI plus 1. Okay, that is one move. Okay, swapping to adjacent elements, and we need to return the minimum number of moves we require to make it a good array. If it is not possible, if it is not at all possible to make it a good array, then we the output becomes -1. We return -1. Okay. So we see the constraints here. The constraints are very low. So from here we can get an idea that brute force will work. Okay. 100 means, in fact, big O of n square time complexity is good to go, right? So from here we get that idea. Then suppose, yes, test case is 1 2 3 1, right? This is C already a good array, right? One first and last element are equal, so it's already a good array. And since it's already a good array, no swaps, no moves are required. Zero, answer is 0. In 1 2 3 4, we cannot make it a good array. Okay, whatever swaps we try, we cannot make it a good array. So your answer is -1. Okay. Now from here also we can get the idea that why we can't make it a good array. It's not possible because for making a good array, we need at least uh, uh, the array like I mean, one of the elements should have frequency greater than 1, right? In order to make it a good array. But here, all the frequencies are all only unique elements are there. The array is having all the unique elements. Then obviously we won't be able to reach out in making a good array. Now here, if we take this test case, here I've explained it. Okay, here if we take this test case, yes, 1 2 3 1 2 3, right? So first we are swapping here. We are swapping 2 and 1. Okay, we are swapping this. So after swapping this, 2 and 1 get swapped. So this is the array we get. Then again we swap 2 and 3. Okay, we swapped these two, and we reached into the final good array. Okay, that is, we have 2 at the end and at the beginning, right? The answer becomes 2 because we went for 2 moves, and this is the minimum number of moves that will make it a good array. Okay. Now, the thing is, idea is that if an element, like you can see from here, see, 2 is like it is the beginning, right? And we are swapping 2 with 1. So, uh, from here we can see that if an element is particular units away from one of the ends, so we can move to the edge in B moves. Okay. Suppose this element is D units away from one of the ends. So we need to move, like we can move to that particular edge in D moves. Okay. Now, the code is based on that approach only, that I have used a brute approach, and time complexity is big of n squared, because big of n squared works fine in this case, in according to the constraints. So what I have done is, the approach is that for every element from the beginning, we find if there exists an equal element from the back, and then we take the minimum value of the sum of distances of the front element from the start and back element from the end in each iteration. Okay, this is what I have done here. That is, in the first loop, I have started from 0 to n minus 1, and in second loop goes from n minus 1, that is from the back to before I. Okay. So here I have compared that if I have compared every element from the beginning with the elements from the back. Okay. So if array of j is equal to array of I, then I have computed the sum. That is, sum is the sum of the distances from the distance of the position from the front edge to the back edge. Okay. So here also we can see that from the test case, that if this is the front element, okay, simply if you see the index 0 and 1, right? So 1 is the distance from the front edge. That is, the index is the distance from the front edge. So I have added I, and from the back side, if we see 2, then 0, 1, 2, 3, 4, 5, right? So 4, I have calculated the distance from the end to that particular index. So I have subtracted the end in n minus 1 with that particular position. So I have got that amount of moves which we need, which that particular element needs to reach the end. Okay. So that is what I have done here. And I have also calculated minimum at each stage. Okay. That is the minimum sum that we are getting till then. That is what is supposed to be the answer, that what is the minimum amount of moves we require, right? So that's how we get the minimum moves which will make the array good. That is, make the first and the last element equal. Okay. So here I have used the map for calculating the frequency, and if the like I have taken a flag as 1. Now, if the frequency, if the frequency of any of the elements is greater than 1, then I have set the flag to 0 and I have broken. Okay. So here, if the flag is never set to 0, that means it's okay. And if the flag remains 1, like if the flag remains 1 and is never set to 0, then we return -1. That means we don't get a single element whose frequency is greater than 1. Okay, so I hope it is clear.
Hello everyone. I hope that I'm audible to everyone out here. Just put a thumbs up if you guys right. So how many of you gave today's contest? Anyone? Okay. So we will be starting with Div Force fourth question now, which is magic mirror. So do anyone of you have any approach for the question? Let me read out the question for you till then. Magic mirror, it describes a long time ago. It's all useless piece of information. The main thing is that we have 1, 2, 3, 4 from left to right written on a piece of number which is infinite. So we have all these boxes colored white, and we can choose two positions, x1 and x2, which are greater than 1, of course, such that when we put at x1 some light, x1 is colored to black. But if x1 minus xd is colored to black, I mean, so d can be anything less than x1. And again, as it is magic mirror, x2 also gets x2 plus d also becomes colored black. So what piece of information do we have till now? We have got 1, 2, 3, 4 many boxes. Only those which reflected black are mentioned in our answer. Like in the test case, we only got those which are reflected back. Okay. And remember, we can choose any D. We have been written that there exists a choice of x1 and x2, that there is sequence of coloring boxes that would result in exactly these n boxes colored black for any amounts of D anytime. So then we choose two mirrors at x1 and x2, both magic mirror plus, and both reflect at plus d and minus d distance. We need to answer if such an arrangement of x1 and x2 is possible. So if anyone of you who has any approaches for this, you can tell me, or if you were able to think of in a way, we'll discuss it out and see if it had any problems or if you were on the right track, or else we'll start with the discussion of the question. Okay, so first of all, let's observe the test cases of the question. Look, for test case 1, 2, 3, 4, what does it say? We select, let's take this for example. We also know that n is always even and n is greater than 2. So for this case, we choose x1 equal to 3 and x2 equal to 5 and d equal to 0. So x1 minus d is 3 and x2 plus d is 5. So exactly we have two boxes required. Then in test case 2, we have x1 at 2 and x2 at 3. So these two are the mirror. First we reflect at d is equal to 0. Then we reflect at d is equal to 1, which becomes 1, and then it becomes 4. Similarly, after that, we check if these two, but it gives us no. We'll get to know how it's a no. After that, these two are our mirror. Then for D0, 6 and 7 are reflected. For D1, 4 and 9 are reflected. For D2, 3 and 10 are reflected. Right? So this is how we get to our answer. First of all, let's see how we are able to observe what we are doing here. So these are the x2 and x1, right? So at some distance d, we have a reflection here, and at some distance d, we have a reflection here too. So think if we choose some x1 and x2, which is not at centered, if we have at some distance x here, as we have got all the list of numbers mentioned here, this will be the farthest number mentioned and it will be distance d. But we need some to have a distance d here too. So x1 and x2 can't be at left. Similarly, it can't be at the right. It needs to be at the center. Right. So you look, when x1 and x2 are at center, when x1 and x2 are at center, only we get further time at distance d from both the sides. We have also got mentioned n is even. So this will be, there will always exist two numbers which we can choose as x1 and x2. For our uh, test case, for this, the center we are choosing is 6 and 7, right? So now you see that there can't exist a number between 6 and 7. We have got a test case here, but think of a case if it is like this is in this way, but we can't choose any number between this. If we have got anyone, we will have to choose these two if we have got a number here. Although it is in increasing sense as we have got in our question, but we'll always have to choose the center one because we can always reflect these two numbers, but we can never reflect numbers in between. If we choose this one, 7 and 10 as our x1 and x2, we can always reflect these parts of numbers or these parts of numbers, but we can never reflect between two. So if we choose 6 as x1 and 9 as x2, we can never find and get 7 and 10, right? So we have chosen x1 as 6 and x2 as 9 here. So look, what we do from x1, we are getting at distance d first, then at distance x2. Means x1 is the first where we get our first reflection, and x2 is the first where we get our first reflection, which is at d is equal to 0. Then we check at d is equal to some value. Let d is be equal to x. So if this x between 4 and 6 is equal to this x between 9 and 11, what is the difference? 2. And here also it's 2. So yes, the same d, that is d is equal to 2, gives us the value, right? So now again we check from here the distance from 6, 3 is 3. And from 9, 12 is also 3. So it's again the same distance and we got d is equal to 3 for the case, right? So we can check our solution. And for this test case where it yielded no, first of all, you should get an observation. It's a very crucial observation that we have got in our already mentioned test cases, that for one, 3, 4, and 5. So these two are the centers, and this is at t is equal to 0. This is also at t is equal to 0, right? Then distance between these two is 1, and distance between these two is 2. So these two are not equal. So they are not reflected by the same mirror. If we consider something which is reflected by this as at distance 2, then there should exist a 6 here too. And if it's reflected at distance 1, then here should exist a 2 here too. For a distance 1 and for a distance 2, right? So if the question had asked us to reform it in such a way that we get all the values, then it would have been a bit better. But here we directly get from the observation what we are doing. Okay. So what we are doing, first we are choosing the last elements. Means we are checking this and this. These two, do they have the same difference as these? the first two have same as last two. If not, then we are making the flag false. Then we are else it stays true. Then we are checking for this difference, and similarly it goes on. So this is a very basic code. I guess you can write it by yourself. It's a very brute force. We are checking for half of the array. We are going for one less than the center because we already know if two elements exist, then it will always be a yes, right? So anyone, any doubts with the question? Or if you want to know what um, actually, if you have any doubt, you can ask me. Okay, so we'll move on to our second question. That is the fifth question of our today's contest, which is planting roses, right? So what does the question tell us? The question tells us we have n types of flowers. Each ith flower has ai number of roses. We have m number of pots and have some thing, means some value k. So we have only got two rules. The first rule is that same color means two different color roses can't be together, or they need to have an empty pot between them, and k consecutive roses of same color at max can be possible, or else we need to have an empty pot. That is, we can at max have a k consecutive pots add together. This is what the question says. This is all written in such a way that it shows you much, but it's not actually much. So let's see for an example. For the first test case explained here, if we have got four pots, one potential way of planting roses, 110, 0 means then there is a gap, and then there is 2, right? So what we have got, we have got our M roses. We have three types of roses, 3, 1, and 2, right? So what we can do, we can take from this 3, we can take 2 roses and put them together. They are of type 1, 2, 3 respectively, right? We can take from here 2, as k is 2, so we can't have more than 2. We need to put a 0, that is a gap, and then we see how many pots are left, 4 pots. So we have got a 2. So if the pot number was 5, we could have put two threes here, but we can only put one 3. So this is what we can do, right? So this is what we can do. Similarly, for the case, you see 3, 1, 2. So for this, we have got 4, 2, 2. As we have only one pot, as we have only one pot, we can put at max 1. Sorry, 4 to 2 is the number. So 2 is the pot, number of pots. And here, the first one of kind is 4. So it's already greater than pot. So we are putting here more than 3, right? So we are already filling 2 of our pots. The third, the third example is a good example, as we can have a better understanding. We have got 4, 20, and 3. So we have got 4 types of pots, 4 types of roses, and 20 pots, right? So what we are doing, let's pick up the number, the rows which are 12 in numbers, and we are putting it 3 by 3, as 3 is the maximum we can go. So 3, then there is a 0, means 3 means 1, 1, and 1. So then again there is 3, Then there is the number of pots filled till now is 7. Again, we go with a 0, then 3, then 1, 1, 1, again 0, then 3, and it's 1, 1, 1. So it's like 3 plus 1 is 4, again 3 is 7, then 1, 8, 3, 11, 11, 1, 12, 12, 3, 15. So we have got our answer as 15 here. So not 15 here. So these are the pots. Then again we have got the 14 number value. We have empty pots till now 5. So we can still fill it with 0, then again 3, and it will be a 0. So how many pots we have consumed till now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And how many we have got flowers planted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is 15. And this is our final answer. Right. This is our final answer. So what's the approach? You can see for the question itself. If we have K roses, if we have K roses, we need to fill these boxes, right? And we also get one extra. We use a greedy approach. First of all, we go greedy and we try filling the boxes we have at maximum. So it's like whatever value we have at maximum, we try filling that up. Okay. We have K, what we can fill at max, and we have to spare one box for the extra. So K plus 1 is filled. Again, K plus 1, some value is again filled, right? And this K plus 1 goes on. If we have m number of boxes, think of a case where the m number ends here midway. We'll talk about it, but that's the edge case, right? But think of a case where we have filled all our empty boxes. We have filled all our empty boxes with the maximum values available first. So we have filled, think if we had 15 roses and we could have only filled with 2, then you see we have filled these 2, then again these 2, and it would have consumed us how many? So this fills 7. You can fill 7 into 2, 14 roses with it, plant, and it will take 21 pots, as we have 7 pot gap too, right? And if we have more pots left, it will be 2, then 0, and again 2, then again 0. Like this, it goes on. And at 0, then 1. This will be last 15, 1. But think if we only had 14 pots, then it would end in not 21. This ends in 22, but that would have ended in 20th. So how do you find that? And think of a case where at the end we have consumed all maximum amount of pots. That is, we have got our x mod k value, k plus 1 value. Yeah, k, right? So we have consumed these, and then we have some x left. That is some pots that were beyond the maximum, right? Then if we have got all our pots consumed, then we start filling with k type of pots, and we ensure that the k is largest here, right? As the k is largest, then only we get to see it filling up the next. So x1 fills with 1 pot empty, then x2 fills with one pot empty like this. And we know that x1 is greater than x2, right? And it goes on. So first what we do, we are filling our k plus 1th box. So k plus 1 pots take up only k flowers, right? So for k flowers, that is k roses, first we have sorted out the vector which we have got, as we want to fill the maximum amount. We want to empty the maximum amount. So we are filling it with k roses and it consumes k plus 1 pot. We check if we have less than the total pot we require, then what do we do? If in a case, if we have only got pot still here, then for the last pot we have got, we will fill, and for this, we take out the remainder. We cannot fill the whole thing with k plus 1, so we take out the remainder. Why do we do a minimum of k or m mod k plus 1? Because these are the m pots and we have already consumed k plus 1 spaces. We have already consumed k plus 1 spaces, and here a little bit of part has been left, which is k mod m mod k plus 1, right? Or if this is a place where we can fit k boxes, means k flowers, then we will put k. And putting k means what? That there is no empty pot at the end, right? So this is what the statement means, that if we have m boxes, but which is less than the number of flowers in total, we put it as k and we write m is equal to 0. What does it mean? It means simply that we have consumed all our boxes. What is C? C is the count of number of roses we have planted. So C is what? C is m divided by k plus 1. That is all these parts taking the boxes. So m divided by k plus 1 into k. As m is divided by k plus 1, it only contains for each k plus 1, we have only got k number of roses, right? So it's k by k plus 1 into m. Okay. And it's minimum of whatever it is left in here for k or mod of k plus 1. And if it's not the case, if we have got plentiful of boxes, what we simply do is we keep adding until it's emptied. Right? We keep adding all the roses for k of z. That is, and we deduct the number of pots by k of 1 into z. Where what is z here? Z is the same thing what we are doing here. So what we can write z as, it is simply x by k. So what we are getting is the integral value of k, and we are multiplying it with, means integral whatever you say, the quotient, and that is multiplied, and we know for each k flowers we consume k plus 1 pots, so we deduct this. Now what we check, that after we have consumed all our huge amount of flowers, and if still pots are remaining, then what do? We again sort the vector thing, and we have updated one more thing here, that we have updated x as x of k mod, x equal to x mod k. So this is why, because we have consumed all our flowers in this, which were an integral multiple of k, right? And we have some remainder left, like 1, then 2, then again 3. Maybe if k is larger, like 4, uh, again 1. Then what do we need to do? We need to fill the next remaining pots with the maximum amount available, right? So you want to fill it with 3. So this is actually V becomes the remainder array, the remainder of pots remaining. So we again sort the remainder array and then perform the same operation. You already checked if the remainder is 0, that we have no flowers of the same type remaining. So we continue the loop, or else if the number of pots is less than the number of flowers remaining, that is, I told you, guess, if after doing our calculation for the maximum, we have 3 as remainder left, then what do we do? And if we have pots, if we have only 2 pots, right? So we cannot fill 3 roses in 2 pots. Okay, so we try filling it with 2. If we have only got 3 pots, then we had full it with 3, but we cannot then have a space. Then for the same thing, what we do, we increase the count and make m as 0 and increase the count by m or x. We are not doing this particular thing here because we already know that what we can increase at max is m or x, right? So else if we have enough space for going another box, so we can choose something here and we have +1 added so that it's an empty box. And then again we check if we have got all our pots consumed, then we simply return the count of the roses planted. You can see the code runs properly and the logic is fine too. So this was my test case which I was trying to run. So this is for a single test case. What I did, 2, 5, and 2. So look what it means. So we have got 3 roses. Means we have got 2 roses each of 3. So 5 pots. What we do first, we can go at max 2. So we first fill these 2, right? Then we fill the another 2. How we are doing it? We are taking the minimum of m mod k plus 1. If there only would have been 4 pots, then this thing would have worked. Then we have filled only 1 pot here, and as it is k, that is 5, we are filling 2 pots without a space, right? So this is what we are doing. Again, if we had extra pots left, some extra pots left, and after doing it, what we had got, the remainder would have been 1 and again 1. So we can put a space here and we can put remainder 1, then again a space here and again then 1. So it is taking 1, 2, 3, 4, more than means more 4 pots. So it's total of 9 pots. So this is how you can do the question. So if you have any doubts regarding the question, you can ask me. If you have any doubts, you can ask me. If everything is clear, you can leave the meet.